12.5. We're going to solve simple, easier logarithmic equations. We'll work our way up to exponentials. We'll also deal with more difficult logarithmic equations in 12.6. So for now, we're going to do the basics. So this first one is super basic because if you have the left side equal to the right side and they already have log base 4 equals log base 4, do you even really need the logarithms? So I'm going to present to you two different ways of solving. Here's what you're looking for. Option number 1, if you have a log with a base and that is already set equal to a log of a base, you have to drop the logarithms. You don't need them. It makes logical sense that if log base 4 of x equals log base 4 of 6, x has to equal 6. So option 1, you can drop the logarithms because you already have one on each side. If it's not option 1, it has to be option 2. There's only two things to do here, and that is when you only have one logarithm on one side. So let's say you had log base 2 of x equals 4. Well, since we can convert from bay to bia to the base raised to the exponent 4 equals the answer. I call this the loop swoop. 2 to the 4 equals what? So x must equal 16. It really is that simple. You either get to drop the logarithms and solve like normal, or you only have one logarithm and you just do the loop swoop. You just convert from bay to bia. So on this first one, we drop the log base 4s. This is algebra 1. 2x plus 8 equals 6x minus 12. We'll subtract the 2x's. We will add 12. So 20 equals 4x. And x equals 5. You do need to check your answers, but it's very simple to do the check. You just plug it in. So if I make this x a 5, I have 10 plus 8. So the left side is log base 4 of 18. If I make this x a 5, I have 30 minus 12. 30 minus 12 is 18. I'm thinking we have a winner. Now, example 2, I figured I only need one of those first examples. That's like option number 1, because I can't make that easier. Drop the logarithms and SADMAP. You'll be fine. So option 2, here we go. We only have one logarithm. So all we're going to do is we're going to do the loop swoop. We're going to convert from bay to bia. The base is 7. The exponent is 2. And the answer is 3x minus 2. I don't write it out like that anymore. I literally just do loop and swoop. That's a lot. I know. I'm sorry. Let's get some of that going. So I do 7 to the second equals 3x minus 2. So 49 equals 3x minus 2. So we're going to add 2. 51 equals 3x. We'll divide by 3. X equals 17. Now, when you get to the next example, and yes, of course, you can check this, 3 times 7 is 51. 51 minus 2 is 49. Is log base 7 of 49 equal to 2? Well, is 7 to the second equal to 49? Yeah, that checks out. All good. Remember, if it doesn't check out, that's the word extraneous. You can have extraneous solutions. We'll cross that bridge when we come to it. We're not quite ready for that yet. That'll probably be next lesson. Now, third example. Again, your options are, it's either there are two logs on opposite sides that you get to drop, or there's one log and you have to loop swoop. So that's it, only two options happening here. On the one we see here, these are not on opposite sides. If they were on opposite sides, I would have to subtract a logarithm, which sure makes it look like to me like it's a little bit more messy. So you get to use your log properties to condense first. So yes, there are basically two very simple options, but also, yes, I realize sometimes you have to do a little bit more to make them into one of those simple options. You have to manipulate it. So let's see what we can do. We can condense it. I want to remind you that when you see addition, it condenses the logarithm back through multiplication. When you multiply the variables, you add the exponents and vice versa. So if I combine these into one logarithm, I'm multiplying the x and the 2. There it is. I also want to remind you that when you don't see a base, it's the common logarithm, it's 10. So clearly we have the second option. That is so messy, I'm so sorry. It's getting later and later when I'm making these videos. I apologize. You deserve better. So how are we going to do this? We're going to loop it, swoop it. We're going to convert from Bay to Bia. 10 to the first equals 2x. If 10 to the first equals 2x, well, 10 to the first is just 10. So we divide by 2, and clearly x equals 5. That was weird. Okay. How can we check it? Log of 5 plus log of 2 is supposed to equal 1. When you condense it, that is not log of 7. It condenses back through multiplication, and 5 times 2 is 10. So is, in fact, the implied log base 10, of course, is log base 10 of 10 equal to 1? Well, from the last lesson, you should remember that we have double 10s. So it's like they cancel and that exponent just drops down. But even if you didn't recognize that, even if you're like, oh, I don't know. So let's convert it and see what happens. Is 10 to the first equal to 10? Is 10 to the first equal to 10? Yes, it checks out. Now notice my answer isn't 10. My answer is x equals 5. I was checking it by plugging it in and see if it made sense. So option 1, logs on opposite side. Logs on opposite sides. You can drop. Option 2, 1 log, you can loop swoop. They're on the same side. Moving that logarithm over there, I'd still have it weird. That doesn't work. I look at that and I'm like, I don't know what to do with that. So condense first and then determine. Get it to where you've got 1 logarithm on one side and 1 logarithm on the other side, if there is one, and see which option it is, option 1 or option 2. So how do we condense when we see subtraction? I want to remind you that when you subtract, it's division. That's supposed to be a little bitty divide. That is too teeny tiny. I think I just made that worse. Yeah, that's awful. All right, to subtract is to divide. So if I condense this into 1 logarithm, it's the left one divided by the right one. The one that has the minus is the one that goes in the bottom. So we have log base 10 again. It's implied to be there. So 10 to the second equals x over 4. 10 to the second equals x over 4. Well, 10 to the second is 100. And to get x by itself, I would need to multiply by 4 on both sides. So x equals 400. Is it large? Yes, it is. Is it wrong? Nope, it's not. Let's prove it. If x is 400, that should make sense. So if x is 400, that's supposed to make sense. Let's see what happens. That's not 396. that is 400 divided by 4. 400 divided by 4 is 100. The implied 10 is right there for the base. Is 10 to the second 100? Yes, it is. 400 works. Not much left. Option 1 or option 2? Well, clearly we haven't had another option 1 because they're just so basic and so easy. So let's practice some more option 2s where you gotta condense and then loop swoop. We change it from bay to bia. So let's get one logarithm together. Log base 2, I see subtraction, which means division. So x plus 3 is on the top, x is on the bottom. Okay. We have one logarithm, that's option number 2. We're going to convert using loop swoop from log is bay to exponential is bia. 2 to the second equals all that business right there. 2 to the second equals x plus 3 over x. Believe it or not, you have the skills to handle that. If I'm trying to get x by itself and x is in the denominator, my first step is going to be getting that sucker out of there. So I'm going to multiply by x on both sides. So 4x on the left equals x plus 3. I'm sorry, it's getting really late. That's going to bug me. Go slower. 4x equals x plus 3. I will need to get my x's together. So 3x equals 3. And clearly, x equals 1. That's a 3. X equals 1. Let's check it. Log base 2 of 1 plus 3 minus log base 2 of 1 is supposed to equal 2. Well, clearly that's a 4. When I condense those to one logarithm, I have log base 2 of 4 over 1 is supposed to equal 2. So is, in fact, log base 2 of 4 equal to 2? Well, is 2 to the second equal to 4? Yes, it is. 1 is our winner. Okay, I'm hoping you're starting to catch on. Condense. When you see subtraction, it means division. Negative 4x goes in the top, 3 goes in the bottom. Loop swoop, converting from bay to bia, from logarithmic to exponential form. 6 to the second equals negative 4x over 3. So 36 equals negative 4x over 3. That's a positive 3. We're going to multiply by 3. 90 and 18, 108 equals negative 4x. Divide by negative 4. I believe that is 27. 80 and 28. Yeah, good. Negative 27. So x equals negative 27. Now, very often when you get a negative, a lot of times it's going to be extraneous. That's not the case this time. This is when a negative is totally fine. Check it and watch what happens. I'm going to need some extra space for this. So I'm going to check this one. Log base 6 of negative 4 times negative 27 minus log base 6 of 3 is supposed to equal 2. A negative times a negative is a positive, so we don't have an issue. What I do need to make sure you understand is why, if that is a negative, you would have an issue. See, you can't take the logarithm, no matter what the base is, of a negative number. That can't be a negative. Do you remember what the parent function looks like? Where you have the vertical asymptote, and then shoot, there it goes. There are no negatives. at least not for the parent. You can shift it and make it go over there, but you still can't take the log of a negative number. So when you have log base 6 of 108, it could have been a negative if that was a positive 4, and then you would have had a problem. It wouldn't have worked, it would have been extraneous. But because the negative times the negative turns that into a positive, we have no issue. When you put those together, log base 6 of 108 divided by 3, 108 divided by 3 is 36. So you have log base 6 of 36 equals 2 is 6 to the second equal to 36 when you change it from Bay to Bia. Yes, it is. Negative 27 is not extraneous. It works just fine. Okay, last one, looks like. Yeah, sweet. All right, last one. Let's condense. Log base 2, you see a plus sign. That means you're going to multiply. So we have 16x, and that equals 8. That's not a grade 8. Okay, fine. Log base 2 of 16x equals 8. So 2 to the 8th equals 16x, excuse me. 2 to the 8th equals 16x. Well, 2 to the 8th, if memory serves me correctly, is 256. I should have checked that before I started making this video because I can't remember exactly. Let's see, that would be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is, yep, I'm right, 256. So, I don't know why I just put an 18 there as well. Nope, that's a 16. So 2 to the 8th is 256. We're going to divide by 16. Coincidentally, 256 divided by 16 is 16. All right, let's check it. I'm going to need some space when I do this one as well. I'll make it go down in a minute. Log base 2 of 4 times 16 plus log base 2 of 4 equals 8. So log base 2 of 64, it's 4 times 16, plus log base 2 of 4 can condense through multiplication. 64 times 4, take a guess. 64 times 4 just happens to be 256. And 2 to the 8th is 56. So 16 totally works. Next time in 12.6, we're going to do some more difficult ones. Once these get good, once you get comfortable, we need to make sure you handle what's extraneous and what's not extraneous. So that's coming in lesson 2.6. See you then.